Okay, right, I'm going to use the demoivre's theorem, two examples here. I'm going to do 1 plus I to the power of 15. Okay, so the first thing I need to do is do an Argand diagram so that I can find out the argument and the modulus. Okay, so 1 plus I is going to be, say, here. That's going to be 1, that's going to be 1. The modulus is going to be root 2. The argument is going to be pi over 4. Okay, simple trigonometry tells me that. So I'm going to rewrite this as root 2 cosine of pi over 4 plus I sine of pi over 4. And what I'm going to do now is I'm going to raise that to the power of 15. Okay, and using de Moivre's theorem, I will write this as root 2 to the power of 15 cosine of 15 pi over 4 plus I sine of 15 pi over 4. So I've got a new modulus and a new argument, okay? But what you've got to do is you just got to recognise there that that argument, the new argument that we have, 15 pi over 4, is greater than 2 pi, okay? So you need to spot when that is the case, because essentially what's happened is your argument has gone all the way around and then round some more, okay? So exactly how much round has it gone? We can rewrite 15 pi over 4 as 8 pi over 4, and I write it like that because that is the same as 2 pi plus 7 pi over 4. Okay, so an argument of 15 pi over 4 is the same as an argument of 7 pi over 4. So I hope you understand that. So I'm going to rewrite this as root 2 to the power of 15 of cosine 7 pi over 4 plus I sine of 7 pi over 4. Because now what that is going to be able to help me do is work out what those values are. So let's do cosine. Okay, cosine looks like this. Okay, so basically, if this is 2 pi, well, 7 pi over 4 is here. That's a distance of pi over 4 from there. So it's going to be exactly the same as pi as whatever this distance. Sorry, this is going to be 7 pi over 4. So it's going to be exactly the same as pi over 4. So that's going to be root 2 to the power of 15. So the cosine of pi over 4 is root 2. Do you know what I'm going to do? I'm going to rewrite this as 1 over root 2. Maybe you'll see why that will be helpful, rather than writing it as the rationalised form, which would be root 2 over 2. I'm going to write it like that, okay? Let's just quickly assess the sine one. So the sine of 7 pi over 4, that would look like this. Okay, so that's 2 pi. So 7 pi over 4 is going to be the negative version of pi over 4. So that's going to be minus 1 over root 2i. Okay, it's the negative version. So now let's expand those brackets, and you can hopefully see what I've done there is if I leave the root 2 at the bottom, it means I can cancel things out. So I'm going to get, let's just go up here. I'm going to get root 2 to the power of 14 as my real part, minus root 2 to the power of 14, I as my imaginary part, and that's going to be the same as 2 to the power of 7 minus 2 to the power of 7i, which is going to be equal to 2 to the power of 7 is 128 minus 128i. Okay, and that is the right answer. It didn't take as much work as doing a massive long binomial expansion. Let's just do it for 1 minus I root 3 to the power of 11. So again, let's find the modulus and the argument. So little argon diagram. 1 minus I root 3. So that's going to be, say, somewhere like this. Let's change colour. So this is root 3. This is 1. This is my argument. And the modulus is going to be 2. The argument is going to be root 3 over 1, so root 3. So arctan of root 3 is equal to pi over 3. Okay, i.e. tan theta is equal to root 3, so theta is equal to pi over 3. Again, that's one you should know. So we're going to rewrite this complex number as the modulus is 2 cosine of pi over 3. Hang on, I'm being silly here. Let's look at it very carefully. You'll notice that the argument is negative pi over 3. So don't fall for that trap like I nearly did there. Plus I sine of negative pi over 3. Because remember, the argument is always measured this way round. But I can measure it this way around as well, but I have to take the negative. Okay? Which means I can rewrite this as 2 cosine of pi over 3, because remember that identity, minus I sine of pi over 3. Remember that identity. Cosine of negative theta equals cosine of theta, and sine of negative theta equals negative sine theta. Okay, and what I'm going to do now is raise everything to the power of 15. 11. Question is 11. Okay, so I can rewrite this as 2 to the power of 11 cosine of 11 pi over 3 minus I sine of 11 pi over 3. Okay. Notice again that the argument is more than 2 pi. Okay, so how can I rewrite 11 pi over 3? Well, that is the same as 6 pi over 3, which is 2 pi, plus 5 pi over 3. So again, I'm going to rewrite as 2 to the power of 11 cosine of 5 pi over 3 minus I sine of 5 pi over 3. Okay, so let's just move it over here. So that's going to be equal to, well, I need to know what cosine of 5 pi over 3 is. Let's just do it quickly. If this is 2 pi, this is going to be 5 pi over 3. So that distance is going to be pi over 3. Cosine of pi over 3 is going to be positive a half. So it's going to be 2 to the 11 times a half minus, well, I hope that you can work it out yourself now. That's going to be, with the sign, it will be negative root 3 over 2i. So it will all come together. A negative will become a positive. Okay. Now, what we can do is we can start to cancel things off. So hopefully you can see that's going to become 2 to the power of 10 plus 2 to the power of 10 root 3i. 2 to the power of 10 is 1024. So it's 1024 plus 1024 root 3i in Cartesian form. Okay, let me know